It used to be that everybody digitally wanted to make it look like film,
Right.
and we'd kind of like to skip that. We just say, no, we want to make it look great.
Our objective is to see if we can make movies with higher impact and greater production value. It's possible that this ShowScan digital process could solve a number of serious problems that have plagued the movie industry since its inception. The whole world has adapted to 24 frames a second in a movie theater. That's what a movie texture is like. That's what people expect. Every filmmaker wants to put exciting action on the screen, but at 24 frames a second, just when you want the most excitement is when you get the worst blur.
Ready?
Speed.
On the left is a timeline of 24 frames representing 1 second, divided into 24 frames and 24 shutter closures. On the right is the same 1 second period, now divided into 120 frames without any shutter closures. When you shoot a movie at 24 frames a second, half the time the shutter's closed and half the time the shutter's open. And so half the action is lost forever. It's simply not recorded while the shutter's closed. Now with electronic cinematography, it's no longer necessary to think of movies as a rigid series of photographs. We've been using this strobe disc in order to check not only the frame rate, this is 24 frames right here, it's actually moving but it seems to be fixed, but it also allows us to check the shutter opening right here, so we can see that we're not only getting 24 frames, but that there's no shutter aberrations being introduced by 60 frames or other frame conversion algorithms that might be buried inside the camera. Having shot our original images at 120 frames per second, we can combine 3 frames into 1 and delete the next 2 to get 24 frames per second.
What's really exciting to me is that we shot material at 120 frames, and we can look at it any way we want.
We've already proven the key aspect of this, which is that shooting at 120 frames and going down to 60 and 24 definitely works just fine. Looks exactly like if it was shot that way. We derived 60 by deleting every other frame. The crispness of the 60 frame derived from 120 frame is strikingly not blurred. We get into blending and bringing in 60 frame material into a 24 frame larger frame.
This performer in white will be running at 24 frames per second, and this performer in black will be running at 60 frames a second. All of this photography will be produced at 120 frames per second to give us as much motion data as we need.
This is obviously a filmed sequence. We have photographed it at 120 frames per second, and we have stored substantially clearer and less blurred action than you see here. We want to retain the 24 frame per second standard, but we believe that we can embed high frame rate motion elements. If a fist moves across the screen and it blurs, just that part of the frame, we can up-res it to a higher frame rate to retain clarity in that motion. We simply make a movie that combines both 24 frames per second and 60 frames per second where it is needed.
If you were making a film, you could decide, I want this film to have the film look, or I want this scene to have the frame integrated motion analysis.
We can use this for Dragon Force. The fight scenes would be shot with this technology.
We are at 120 frames per second, 360. Our stop is what? 280 above.
Sure looks good. ShowScan Digital automatically increases the clarity and the impact of fast action elements while preserving the world standard 24 frame film texture. The transition of film production and exhibition to an all digital medium is being driven by 3D. Yet 3D suffers worst from the shortfalls of 24 frames. Aside from the obvious blurring, when frame-to-frame motion of an object on the screen matches or exceeds the interocular left eye, right eye displacement, the entire 3D effect is lost. Now it is no longer a question of whether digital photography and projection are able to emulate film. They can be far superior in 2D and 3D.